Thermodynamics. Energy equivalent to 1 erg, 1 joule and 1 calorie are in the order 1 calorie is greater than 1 joule is greater than 1 erg. During an isothermal expansion of an ideal gas, its internal energy decreases. False. During adiabatic compression, the temperature of the system decreases. The heat absorbed during isothermal expansion of a gas against vacuum is zero. True. In an exothermic reaction, the value of delta H is negative. The state function are internal energy, enthalpy, entropy, which is not a state function. Work. Bird flying in the sky, open system. Hot water placed in a kettle, closed system. Boiled water placed in a thermoflask, isolated system. An extensive property is enthalpy. Statement 1. During isothermal expansion of an ideal gas, there is no change in the internal energy. Statement 2. During isothermal expansion of an ideal gas, as temperature remains constant, no heat enters or leaves the system. Both statement 1 and statement 2 are true. 1.2 gram of magnesium react with excess of dilute acid at 27 degrees Celsius at the atmospheric pressure. Calculate in calories the work done against the atmosphere by evolving hydrogen gas. 30. 3 mole of an ideal gas at T degrees Celsius expands isothermally and reversibly to double its initial volume. If the maximum work done by the gas is minus 5.187 into 10 power 10 ergs per mole, calculate T degrees Celsius. 27. The isothermal expansion of an ideal gas. Delta U is equal to 0. W is equal to minus Q, delta T is equal to 0. An ideal gas of 3 moles initially at 27 degrees Celsius and 2 atmospheric pressure is compressed isothermally till the final pressure is 8 atmospheric pressure. Calculate Q for the process minus 10,339 joule. In an isothermal reversible process, oxygen gas is allowed to expand from 15 meter cube to 16 meter cube at 400 Kelvin and the work done by the gas is minus 19.147 kilojoule. Calculate the number of moles of oxygen in the sample. 4.17 moles. Calculate the internal energy change in which 10 kilojoule of work done on the system and 18 kilojoule of heat is given out by the system. Delta U decreased by 8 kilojoule. Calculate the internal energy change when 1 mole of an ideal gas is compressed adiabatically from 10 liter to 4 liter against constant external pressure of 2 bar. Let 1 liter minus bar is equal to 100 joule plus 1200 joule. Assertion. The heat absorbed during isothermal exposition of an ideal gas against vacuum is 0. Reason. The volume occupied by the molecule is 0. Assertion is correct but reason is incorrect. For the isothermal free expansion of an ideal gas against vacuum, delta U is equal to 0, Q is equal to 0. The heat of combustion of isobutane at 298 Kelvin is minus 2871.59 kilojoule per mole at constant pressure. Calculate the internal energy change minus 2863 kilojoule per mole. Delta U for the reaction CO plus of O2 it gives CO2 at 300 Kelvin is minus 281.7 kilojoule. Delta H for the reaction at 300 Kelvin in kilojoule is minus 280.5. A thermodynamic system absorbs Q1 calories of heat at temperature T1 and Q2 calories of heat at temperature T2. If the internal energy of the system is raised by 1 Kelvin calorie during the process, the amount of work done is 1000 minus Q1 plus Q2 calorie. In which of the following reactions delta H is equal to delta U? 2C plus H2 it gives C2H2. The enthalpy of vaporization of C2H5OH is 43.5 kJ per mole at 40 degrees Celsius. Take the vapor pressure as 700 mm. Calculate delta U for vaporization in kilojoule per mole 41. Relationship between Cp and Cv for 1 mole of ideal gas. Cp minus Cv is equal to R. The specific heat of a gas at constant volume and constant pressure are 0.037 calorie degree power minus 1 gram power minus 1 and 0.062 calorie degree power minus 1 gram power minus 1 respectively. The atomicity and molecular mass of the gas is monoatomic 80. Cp by Cv ratio for CO gas molecule is 7 by 5. Calculate the energy needed to raise the temperature of 5 gram of a solid substance X from 300 Kelvin to 800 Kelvin. Given specific heat capacity of X is 0.62 joule Kelvin power minus 1 gram power minus 1 1550 joule. The average molar heat capacities of water and ice are 75.6 joule per mole and 37.8 joule per mole respectively. An enthalpy of fusion of ice is 6.012 kilojoule per mole. The amount of heat required to change 20 gram of ice at minus 10 degrees Celsius to water at 10 degrees Celsius would be 7940 joule. A system that exchanges matter and energy with the surroundings is known as open system. A process in which system does not allow exchange of heat between itself and surroundings through its boundary is called adiabatic process. In which of the following causes delta U is equal to 0? Cyclic process, isothermal process. The one which depends only on the initial and final states of the system and not on how the change is carried out is sum of Q and W. The correct statement for first law of thermodynamics is delta U is equal to Q plus W. 3 moles of an ideal gas expanded spontaneously into vacuum. The work done will be 0. Correct option for free expansion of an ideal gas in an adiabatic process from the following: Q is equal to 0, W is equal to 0, delta T is equal to 0. The work done when 1 mole of water at 373 Kelvin vaporizes against an atmospheric pressure of 1 atm is 3100 joule. 18 gram of a gas at STP on performing a work of minus 11.2 liter atmosphere expands to double its volume. The molecular weight of the gas is 36 gram per mole. A system consisting of 4 moles of an ideal gas at 27 degrees Celsius is allowed to expand reversibly and isothermally from 5 liter to 50 liter. The work done during the process is minus 23 kilojoule. Is an isothermal reversible expansion process of 10 moles of an ideal gas. Pressure is decreased from 10 atm to 4 atm. Calculate the temperature if the work done is minus 24.22 kilojoule per mole, 318 Kelvin. A gas is allowed to expand in a well-insulated container against a constant external pressure of 2.5 atmosphere from an initial volume of 2.50 liter to a final volume of 4.50 liter. The change in internal energy delta U of the gas in joules will be minus 505 joule. Relation between change in enthalpy and change in internal energy. Delta H is equal to delta U plus delta Ng or T. The heat of combustion of C6H5COOH at constant volume measured in bomb calorimeter at 298 Kelvin is minus 3222.76 kilojoule per mole. Calculate the value of delta H minus 3224 kilojoule per mole. 1 mole of an ideal gas at 300 Kelvin is expanded isothermally from an initial volume of 1 decimeter cube to 10 decimeter cube. The value of delta U for the process is 0. If 4 kilojoule of work is done on the system and 1 kilojoule of heat is given out by the system, the change in internal energy plus 3 kilojoule. The enthalpy of vaporization of a liquid at 500 Kelvin and 1 atm is 10 Kelvin calorie per mole. The change in internal energy for the vaporization of 2 moles of the liquid at the same temperature and pressure is 18 kilocalorie. The difference between the heat of reaction at constant pressure and constant volume for the reaction 2C6H6 plus 15O2 it gives 12CO2 plus 6H2O at 300 Kelvin is minus 7.5 kilojoule. Under isothermal condition, a gas at 300 Kelvin expands from 0.1 liter to 0.25 liter against a constant external pressure of 2 bar. The work done by the gas is given that 1 liter bar is equal to 10 joule minus 30 joule.